Today we're going to analyze graphs of polynomial functions. And the good news is we have seen most of this before. We're just going to try to pull it all together. And the nice part on this first problem is that the graph is already given to us, and then we're just going to answer questions about it. But on A and B and C, we get some old vocabulary. Relative maximum, relative minimum, absolute maximum, absolute minimum. The thing that we need to remember is that absolute maximum, absolute minimum are the highest points on the graph. And as we take a look at this graph, over here to the left, what happens is our graph is going to continue going downward. I don't think you need to write it down, but on the video, you need to see what I'm referring to. We're going to keep going down. And on the right, we're going to keep going up. And because we keep going downward and we keep going upward, we do not have an absolute maximum, nor do we have an absolute minimum. An absolute maximum is the highest point on the graph. An absolute minimum is the lowest point on the graph. And we have some high points in the graph and some low points in the graph, but they're not the highest point or the lowest point. So that takes us back to letter A. State the relative maximums of this. Well, one of the relative maximums is this point, -3, 2. It is a high point of the graph. It's not the highest, again, because this graph keeps going upward, but it is a specific high point of that graph. Another high point of this graph is 2, 1. Upon closer examination, we see that we have some low points in the graph too. It's not the lowest point, but it is a low point, like -1, -3. It's a low point in the graph. 4, -1, also a low point in the graph. And that, if you take a close look at all 4 of those points that we just wrote down, they happen to occur at turning points of the graph. Leads us to question D, which says, what is the least degree of this polynomial? Well, when I start to answer that question, again, I go back and I look at the turning points. Here is a turning point. Here is a turning point. Here is a turning point. There is a turning point. There are 4 turning points in this graph, which means that we are working with a 5th degree. That's the lowest degree that we could have in this graph. We actually could have more, but based on the number of turning points that we have in the graph, that's the lowest degree that this polynomial can be. Letter E. Is the leading coefficient positive or negative? Well, once again, remember, look at how the graph is finishing. Our graph over here is going up to infinity. Y is going up to, in fact, we can say positive infinity. Because Y is going to positive infinity, then our answer is, the leading coefficient is positive, because graph finishes at positive infinity. Over what intervals is the function increasing? And we're going to write this in interval notation. And when we start looking at our graph, we're going to start over here to the left. And what happens is we go up, 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 up. So up is going to be an increasing feature. And we're going to start at negative infinity. That's going to be negative infinity to the far left. And then we're going to go to the x value of our point here at the very top. And our x value at that point up here is going to be -3. But once we get up there to the top, what happens then is that our graph starts going down and down and down and down and down and down. So there's a decreasing part of the graph. And you look at the x values to identify them. So we're going to decrease from -3, the x value of that top point, the high point, to the x value of the low point, which is -1. But once we get to that low point, we're going to start an upward direction again. Up, 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 up. So there's an increase. So what I wrote on our increasing is I wrote a U, union, or joins with. We're going to take our x value that we can still see at the very top of the screen here, -1, that's the x value of our low point of our graph, and we're going to go to the x value of the high point, which is 2. But our graph still keeps going here, and it's going to go down and down and down and down. We're always looking at the x values for the increasing and the decreasing, and this is something that we talked about first quarter, coming back again. So it's going to be 2, the x value of our high point to our x value of our low point, 2, 2, 4. And then there's just a little bit more. We're almost done with this graph here. In terms of the increasing and decreasing, we're going to go up, 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 up. So we're going to go joined with 4 to infinity, and that positive infinity is going towards the right on the graph, not going up. It just happens to be coincidence that it's the same way that the polynomial is going. But that's what the bubble says there as well, just a little reminder. Over what intervals of x are the y values increasing and decreasing? And that's why we went back and we labeled all of those values with x's in our increasing and decreasing. Down here on letter H, order pair. Sorry, the question is domain. State the domain and the range of the function. We want to write them, I'm going to write them in interval notation. And the domain for most of our functions, most, not all, in algebra 2 is -infinity to infinity. All real numbers. By the way, the abbreviation for all real numbers, which we saw, is 2 bars with a capital R. We've seen that on some of our entrance slips. But the question then becomes the range. Is the range all real numbers? What we have to ask ourselves is, do we have a high point or do we have a low point in the graph? And we don't have a high point or a low point in the graph. We don't have any absolute maximum or minimum. And because we don't, our range is also going to be all real numbers. And finally on this problem, state the end behavior. Well, the nice thing is we're just going to look at the picture. And the first part says as x approaches -infinity. So going back and looking at our graph, as we go to the left, what's happening is that our graph is going to continue going downward. So y is going to approach -infinity. And as x approaches positive infinity, so we're going to go to the right on our graph, what happens is we're going to keep going upward. And that means that y is going to approach positive infinity. Analyze the graph of the polynomial function f of x equals -0.1x squared times x plus 3 times x minus 4. Degree of the polynomial. Well, a reminder when we look at the degree of the polynomial that this parentheses has a 1 on it and this parentheses has a 1 on it. And what we have to do once we determine what those exponents are is we're going to take 2 plus 1 plus 1, which gives us 4. So this degree of our polynomial is 4. And do you remember, by the way, how do we name a 4th degree polynomial? And hopefully you're thinking in your head, quartic. But anyway, do we need to find the standard form to determine that this is a 4th degree polynomial? No. And standard form means that we would have to multiply that completely out, put it with the highest degree first, then the next highest degree, then the next highest degree. Leading coefficient. Well, leading coefficient is negative 0.1 x squared, so it's going to be negative. And once again, by the way, the fact that our leading coefficient is negative means that even before I get below here and draw this picture, that this is going to be negative infinity. It's going to finish in the direction of your leading coefficient. Maximum number of turning points. Since our degree is 4, there's 1 less turning point than degree. So this is going to be 3. And to help with the end behavior, eventually we're going to have to draw our picture anyway. So let's pull out our calculator and let's at least get the first start of our calculator, of our picture drawn, by typing in this function, negative 0.1 x squared times x plus 3 times x minus 4. And here's a picture. And I know I have a window over there, but I don't even think that we need to change the window. We can see everything that we need to see here. So we're going to draw a rough sketch down here in part F. Looks something like that. And once we see the picture, either on our calculator or on our drawing here, we see that as x approaches negative infinity, in fact, as we're going towards the left, what's happening is we're going downward towards negative infinity. Next step, find the x-intercepts of the graph, state their multiplicity and how they behave at the x-axis. So we've got a good picture, so your calculator could help you with these. But in terms of, say you didn't have your calculator with you for some reason, what we would do is we would take negative 0.1 x squared, and we would set it equal to 0. We would take x plus 3 and set it equal to 0. And we would also take x minus 4 and set it equal to 0 to help us find these values. Again, you could look at your calculator screen because we just drew these already. But if you're figuring this out algebraically, by the way, what you would do on this first one is you would divide both sides by negative 0.1. And that would give us x squared equals 0, because 0 divided by negative 0.1 is 0. And then remember, inverse operation of squaring is square rooting. So what happens is that we end up with x equals 0. Got to squeeze that in there. And in fact, does that make sense in our picture? In fact, it does. There's 0, 0. The exponent is actually the multiplicity of this problem. So our exponent on this is 2. 2 happens to be an even number, so do we cross or do we touch when we have an even? Well, again, we've got our picture. We can see that we simply touch. And lastly, does it behave linearly, quadratic, or cubic? It looks like a U-shaped curve, which is a quadratic. If we go to the next group, a lot easier to deal with. You may not even need to subtract 3 from both sides to get your x equals -3. We put the exponent on there already of a 1. That determines our multiplicity. And in fact, if we come down here, here's -3, 0. Just a label, because we're going to have to label some on this picture anyway. Do we cross or do we touch? Well, an odd multiplicity means that we're going to cross this function. And a linear function is to the first power. So this one's going to be linear. One more over here, the x minus 4 equals 0. We're going to add 4 to both sides. And we get x equals 4. Our multiplicity, going back and looking at the problem, we wrote in an exponent of 1. And once we know that the exponent's 1, it's going to be the same as our previous root of that -3. 1 is an odd number. Whenever we have an odd multiplicity, we cross. To the first power is linear. Second power is quadratic. To the third power is cubic. Which leads us now into part F, which we already have a lot of the picture drawn. And again, we don't need to change the scale. We've got a basic sketch, and I'm going to put one more value in over here, which is this point here. It's the 4, 0. But what we really want is we really want to know what's this point right here. And we also want to know what is this point right there. So we're going to take out our calculators. Again, this goes back a while. We haven't done this for quite a while. But we're going to find these maximum values, if I can get the calculator to pop up. So we're going to go second, trace, and maximum. And then we're going to go a little bit to the left. So somewhere over here to the left, press enter. A little bit to the right, press enter. And then press enter one more time. And what we get, and it says in the directions round to the nearest tenth, is we get -2.1, +2.4. -2.1, 2.4. We need to do the same thing to find this orange point. So we're going to go second, trace, maximum. A little bit to the left, enter. A little bit to the right, enter. And then enter. We get 2.85, so I'm going to round that to 2.9. And 5.46, so I'm going to round that to 5.5, because it says round to the nearest 10. So 2.9, 5.5. Check that one more time. 2.9, 5.5. And now that's going to let us answer a lot of the rest of this picture here. And it says, state all relative maximums. And actually the 2 points that we just found are our relative maximums. the negative 2.1, 2.4, and the 2.9, 5.5. I do want to point out, in this particular case, the 2.9, 5.5 is an absolute maximum as well. It's a relative, but it's also an absolute. It is the highest point in the graph. And we didn't see an absolute maximum on the front of our notes, so there at least we can see an example of that. We only have one relative min in here. It's a low point of the graph. It's not the lowest point. The 0, 0 is a low point of the graph. And then we want to state the intervals over which the graph is increasing. I'm going to start at the far left here. And we're going to go up, 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 up. We're going to go up until we get to the purple point. So it's going to be negative infinity to negative 2.1. The x values when we're looking at the increasing. When we get to the purple point, we're going to go from the purple point to the green point. And when we go from the purple point to the green point, we're going down and down and down and down. So now that's going to be a decreasing. It's going to be negative 2.1 to 0. They look like order pairs, but we do have them in interval notation. But when we get to 0, 0, to keep outlining this graph, we're going to go up, 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 up. We're going to go from the green point to the orange point. So we're going to join, union. We're going to go from 0 to the x value of the orange point, which is 2.9. Then we have to finish one more time. And at the top of the orange point, we're going to go down and down and down and down. So there's the decreasing. So we're going to join this. And where we're decreasing is we're going to decrease from the orange point of 2.9. But we're really going to go to positive infinity. We're going towards the right in the graph. We're not going downward. We need the x value. And the x value is going to be positive infinity. So watch out for that. Lastly, our domain of our function. Well, most of the values of domain in Algebra 2 are going to be all real numbers. And this one is no different. The range is not all reals on this one. And again, when you're thinking about range, you need to ask yourselves, do we have a high point or do we have a low point on the graph? And we just talked about a minute ago that that point, 2.9, 5.5, is a absolute maximum. It's the highest point in the graph. So when we write this, we're going to go from negative infinity to the y value, which is 5.5. And that one's included. Infinity always has a parenthesis. That's our range.